Hello, and welcome to Math Lessons with Linda. Today's topic is the remainder theorem. The remainder theorem is used oftentimes in conjunction with synthetic division. Here's what our problem looks like today. P to the fourth minus 8p cubed plus 10p squared plus 2p plus 4. This is our function. And what we're going to be asked to do is to figure out the value of the function at 2. So the first thing I want to do is I want to use long division for this because I want to figure out what's my remainder if I am dividing this polynomial by what would be x minus 2, or in this case it would be p minus 2, that's our variable. If p minus 2 equals 0, that means that this would be a factor. So what I'm going to do is turn it into this value for x, and I'm going to use synthetic division. So let's copy down all of our coefficients, and let's start our synthetic division. If I drop down the 1 and I multiply, I get 2. I add to get negative 6. I multiply, so now I've got negative 12. I add going down, which is negative 2. Multiply and get negative 4. Add going down here, and I get negative 2. Multiply again, I get another negative 4. And on my last step, I get my remainder, which is 0. When you have a remainder of 0, remember that tells you now we know this p minus 2 is indeed a factor of our original polynomial. Another way that you can determine whether or not something is a factor of a polynomial is taking your value, in this case we had f of 2, and substituting that in everywhere there is a variable in your original problem. So there are many terms in this. We have a lot of substituting in to do. So if I substitute in for each of these, I'm going to end up with 16 minus 64 plus 40 plus 4 plus 4. When I combine all of these together, I get 0. So just like with synthetic division, where I can divide through and figure out what my remainder is, and if I have a factor, I can just evaluate my function at this specific number that I'm given. And if I get a 0 when I evaluate it, that's another way for me to know, oh, the remainder would be 0 if I divided. And that also tells me that my p minus 2 is indeed a factor of my polynomial because I had no remainder. So that's another example of how you can determine whether or not something is a factor of a polynomial using, in conjunction, synthetic division and also using in substitution.